So today we're starting our next unit, Unit 3, which is on systems. We're only looking at systems that have linear equations or inequalities, and we're going to start by looking at how we would solve a system by graphing, since we just came off our graphing unit. So what a system means is that we have a collection of two or more equations. And in our case, linear equations. You could have a system with other types of equations, absolute value equations. Maybe I'll even give you a challenge one with some absolute value equations at some point during the year, or quadratic equations. Any sort of equation can be within a system. And what we want to do is find the solution to this system. And a solution to a system of linear equations is an x, y value that is a solution for all equations in the system. Okay. So what that means when we're graphing, so here's a system. So now we're no longer just saying graph this line or just graph the bottom line. I'm going to have this first line, 4x subtract y equals 2. And so I'm going to go ahead and rewrite this line. And in my first line, I have a slope of 4 and a y-intercept at -2. So I go 0, -2. Now, one thing when we're graphing systems, we want to be super accurate. So if you haven't been using a ruler, you want to use a ruler. And sometimes it's even helpful to get like several points, not just one point using my slope. So rise over run of 4 over 1. I'm going to get a few points. 2, 3, 4 over 1. I could even go backwards. 1, 2, 3, 4. Just so that my line is really accurate when I draw it in. So there's my first equation. Now I have this other linear equation that's in my system, and I subtract x, and I can see that my slope would be -1, and my y-intercept would be at 3. So I go 0, 1, 2, 3, and slope of -1. And I could get more points. The reason I stopped there is I already know my solution. And so kind of what our thought process needs to be here is I have this line that I graphed with my black pen. Every point on this line is a solution to this equation, this first equation in my system. Then I have the blue line, and every point on that blue line, every single point that falls on that line is a solution to this blue equation. Now there's one point right here that falls on both of those lines. So this point, which is 1, 2, this point 1, 2 is a solution for both y equals 4x minus 2 and y equals -x plus 2. It's a solution for this line and a solution for this line. That's the xy value. That's a solution for all the equations in this system. Okay, so before we just had one line. Every point on that line is a solution. Now we have multiple lines, and our solution is where they meet or their intersection point. Okay, this is the solution of my system. Okay, so I have this system, 4x minus y equals 2, x plus y equals 3. The solution of that system is where they meet or where they both have a solution at 1, 2. Okay, that's the solution to my system. Now, what we can do is we can do a quick check of that to make sure that because if I graphed this line wrong or if I graphed that line wrong, I could be off. If I rewrote a line, I could be off. So I'm going to check my point 1, 2. And the way that I could do just kind of a quick check, and this isn't part of my answer. This is my answer. I'm done. I'm just going to go back and check it. where I have these two, and when I check, I go back to the original equations, because again, if I rewrote something wrong, then the check may end up working out, but it's because I used the wrong line. And when I check, I'm just going to plug in 1 for x and 2 for y, which would give me 4 minus 2. 2 equals 2. Get that balance. Okay, so that means 1, 2 is a solution for my first equation, but it doesn't need to just be a solution for this line. It also needs to be a solution for this line. So now I'm going to go ahead and I'm going to plug in 1 for x and 2 for y in my other linear equation, which gives me 3 equals 3. So by checking it, I've proved that 1, 2 works, that it's a solution for both this line and that line, and it's a solution to my system. Okay. So now let's look at a few other setups where we're going to graph and find the solution to my system. Now I've given you some trickier lines to rewrite here. So first I need to take this line and get it into y equals. So I'm going to subtract 4y, I think. It's going to be my first move. And at the same time, I'll add 7. Okay, so that's going to give me x plus y equals 5. Now I need to move that x over, so I get y equals negative x plus 5. My first line has a slope of negative 1 and a y-intercept at 5. So I go 0, 1, 2, 3, 4, 5. Slope of negative 1, I'm going to get several points here just to make my line more accurate. Slope of negative 1. Y-intercept of 5, there's line 1. Line 2 here, if I were to rewrite it, so I'm going to move the 4x and the 7 all at once. So subtract 7, subtract 4x. It's going to give me negative 4x subtract 4. Divide everything by negative 4. So be careful with our signs here. That's going to give me positive 1x and positive 1. Or a slope of 1 and a y-intercept of 1. So y-intercept of 1, slope of 1, and ding, ding, ding. You can see it right there. That's where they're going to intersect. So I don't need many more points here. I've got my solution. So I draw on my other line. And then where these two graphs meet right here, which is at 2, 3, that's the solution of my system. Okay, so I want to also identify it as a solution. Don't just kind of write it and leave it in the mix of all your other work. 2, 3, I'm saying is the solution. Now, again, because so many things could have happened here, or I could have miswrote it or whatever, I'm going to go back and check it. Now, it's definitely going to be a little more challenging to check my original equations here, but it's doable. So here's my first equation. What I do is I just write the first equation, and then here's my other equation. Okay, so those were my two original equations. So I'm saying this point, okay, that I'm saying that 2, 3 is going to work here and here, that it's a point, an xy value that's a solution to both of these lines. And so I'm going to plug in 2, anywhere I see x, and 3, anywhere I see y. And again, I don't want to use the rewritten ones really because I could have rewritten them wrong. So I'm going to check in the original. So now cleaning up what I substituted in here, I'm going to get just a little order of operations, do that multiplication first. And now I'm just going to go left to right with my addition subtraction. So it would give me 17 minus 7 or 10, and negative 2 plus 12 gives me 10. Okay, so far so good. It works, 2, 3 works in my first line, but it needs to work for both. It's not enough to just check one equation. I also have to check over here. So I plug in 2 for x and 3 for y. And multiplication first. And going left to right across the problem, 8 subtract 12 is negative 4, plus 7 is 3. Okay, so I've checked it and it works for both equations. I know that I have the right solution. Let's look at one more together and then I'll let you try it on your own. So again, graphing our systems, first we need to rewrite here. So I'm gonna subtract 2y and add 1 at the same time, which is gonna give me 2x plus y equals 2, or y equals negative 2x plus 2. Slope of negative 2, y-intercept of 2. So I go 0, 2, slope of negative 2, and get a few points just in case. Again, use a ruler to get a really accurate line. My other equation, I'm going to subtract 3x and then divide by negative 3. Slope of 1, y-intercept of negative 4. So 1, 2, 3, negative 4, slope of 1. So if you graph these and you get a point and then you check it and it doesn't work, you can't move on. You got to kind of restart and figure out where did you go wrong. Like if, for example, if I had left this as negative x, then my line would have gone this way and they would have intersected maybe over here somewhere. Okay, so if you graph and then you go to check the point and it doesn't work, that means we got to redo. Okay, so one thing, make sure you're using a pencil, but also don't avoid this check because it's going to kind of guarantee our final answer for us. So I see that they intersect at the point 2, negative 2. So I'm saying this is my solution, but before I submit that as my solution, I'm going to check it. And I'm going to check it in my first equation, which is 2x plus 3y, subtract 1 equals 1 plus 2y. And I'm going to check it in my other equation, 3x minus 3y equals 12. And so for both, I'm going to plug in 2 for x and 3 for y. And the other thing that I've seen students do, it's so sad when it happens, is they mess up the math on their check. And so it doesn't work and they go back and redo it and they are getting confused. So another thing, if you check it and it doesn't work, go back and look at your check. Did you make sure that you, like here, when I multiply that, it's going to become negative 6. Okay, did you do your order of operations in your arithmetic correctly in your check? Is that the issue? Or is the issue that you graphed wrong and you have to restart? Going left to right, this would give me negative 2 minus 1. This is negative 3. Negative 3 equals negative 3. Okay, so it works for my first equation. In my second equation, where x is, I'm going to plug in 2, and where y is negative 2. Gives me 6 plus 6. And that, again, works in my second equation. So I feel good about my solution because I've checked it and I made sure that it worked. So now what I'd like for you to do is flip this page over and you'll see that there are 4 graphs there. Now, some of the graphs are maybe a little more challenging to rewrite, like here. You could either clear the fraction or do the multiply by the reciprocal to get rid of that 1/2. But I want you to rewrite all the lines. So, and don't graph them yet. Okay, so we're going to pause the video and I'm going to have you rewrite all the lines. Then we're going to check in, make sure we rewrote everything okay. And then I'll let you go back and graph them. Okay, so take a moment, 1 through 4, rewrite all of them so that they're easy to graph. Okay, so now let's compare what we have for lines. So what I meant by this one is I just got rid of that 1/2 by multiplying the whole equation by 2. So 1 times 2 is 2, half, it gives me just y, and negative 2x, and then I just had to subtract 2 to get my equation. Okay, so check your equations on 1 and 2. You may need to pause it. I'm not going to spend too much time just sitting and waiting. Check your equations on 2. So equation 1, equation 2. Check your equations on 3 and your equations on 4. And again, you may need to pause it and check them over. So now I'm going to pause my own video and I'm going to go ahead and graph just 1 and 2, and then we'll check in after that. Okay, so for my first graph, this one's a little tricky. So here's my y-intercept of 2, slope of negative 2/3, black line. Blue line, y-intercept of negative 2, slope of negative 2. Now where these lines intersect is actually kind of to the left of the graph. And so you notice how many points I put in. So I went negative 2 over 1, but then I realized like I got to go this way. So I went backwards, 2, negative 1, 2, negative 1, 2, negative 1, boom. Okay, there it is. And so I would say the solution for 1 would be at -3, 4. And then I could go in and check it. And so when you check it, it doesn't have to be super formal. Like if I plug in, like in something like this, I can just kind of look up above. -3 here would make this -6 plus 12. If I had 3 times 4 here, that's going to work. Here, 1 plus half of 4, half of 4 is 2. So that would be 3. -3 is going to be +3 as well. So you can do just kind of a quick check. Certainly, I want you to be writing it out, but just to save time on the video, I'm just going to kind of go with looking it over and moving on. 2 is a little easier. It's always easier if it intersects on the right side of the graph versus the left side of the graph to get the correct intersection point, I think. So here's my solution. Make sure we box our solution. This is at 2, -4. This is where I'm saying the solution is on number 2. And again, real quick check there. So 12 times 2, this would be 24 on this side. This would give me +12, negative times a -4. 12 plus 12 is 24. I feel good about that one. X, Y, 2. So 2 minus 4 is -2, plus 2 is 0, 0, 0. I feel good about that check too. Okay, so now I'm going to give you some time to look at 3 and 4, and we'll compare answers in a minute. Okay, so here are my graphs for 3 and 4. On 3, I'm going to say that the intersection point is -2, 3. And then, of course, you would check it. And on 4, my lines are intersecting at 3, -3. There's my solution. Okay, and that's it. That's all we're going to talk about today. We're going to move into looking at what if I had a system of inequalities instead of equations. And that will we're going to focus on this graphing piece for the rest of next week, leading up to our Thanksgiving break.